We have 8-point charges, positive Q, sit at the corners of a cube of side A. What is the potential at the center of the cube, at the center of a cube face, and at the center of a cube edge? The difficult part of this problem is visualizing what's happening, seeing it in 3D. So that's what we have. We have a cube. Everybody see the cube? And I imagine I have a charge at each one of these corners. Each one of those charges creates its own potential. What is the potential due to just a charge sitting somewhere? Just a general formula for potential of a charge. K times Q over R. So the important things to know, K is a constant. We are given that. Q is a charge. And they tell us that our charges in this problem are a charge positive Q. So there's my Q. And then R. R is how far you are away from that charge. So what we need to know is how far each of these positions are from the different charges. What is the potential at the center of the cube? So the center of the cube is a little circle that we see right here. I drew it in for you, modeled it in for you. So I need to know how far it is for the first part, at the center of the cube. How far am I from each one of the corners? Yep. If I compare the distance from this top corner to the middle to this corner to the middle, how do they compare to each other? They're all equal, right? So I have 1, 2, 3, 4, 5, 6, 7, 8 charges. They're all going to contribute the exact same amount because they're all the same charge and they're all the same distance. So I can right away say that this is going to be V equals 8 times K times Q divided by R. What I need to know now is how big is R. All they tell us is that one side of this, how long is one side? Is A. So it's A length. That's one side of the square. So to get to the middle from a corner, I've got to kind of take a path. So if I want to get to the middle here, I have to kind of move only in X and Y directions and Z directions. So I can move over, I can move in, and then I can move up. That gets me to the middle. That actually gets me this hypotenuse right here. That's the distance that I need to find. So inside of this triangle, that hypotenuse is made up of the triangle that goes all the way slanted up, all the way down, and then along this bottom portion. That's the triangle that I'm working with, but I can work with it in 3 dimensions by going in steps, going in kind of the X, Y, and Z directions. So I can take steps, and I'm getting a hypotenuse, so I can't just add up these steps, add up these distances. How do I get hypotenuse distances? Pythagorean theorem. And I can do Pythagorean theorem in 3 dimensions. I don't have to do it in just 2. So that's all we have to do here. I have to go from here to here. That's one of the directions. How far is it from the corner to the middle? The whole distance is A. How big is this? A over 2. So R is going to be A over 2 squared. And then I need to get from the edge to the middle of the cube. How far is that distance? From the edge to the middle. Right there. It's the same. A over 2 plus A over 2 squared plus, okay, now I have to get from the bottom of the cube up to the middle. How far is that distance? Same, also A over 2. And what do I need to do to this R? I'm adding it like Pythagorean theorem. So I have squared, 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 square root. So there's my R, and my potential is 8 times K times Q divided by A over 2 squared plus A over 2 squared plus A over 2 squared square root. Does that help? Does this help?
Yes.
Would it help to have one of these on your tables when you're taking the exam? They take a long time to print. They took about 4 hours to print. So if you want a classroom set of these, if I need to print 5 of them, then I need to start on it. So if you find it useful, then somebody, anybody, I don't care, send me an email, print the cube dummy. Just put that in the subject line. Print the cube dummy. And I'll print one. Okay? Any questions on this part? There's more parts to the problem, though, aren't there? Stupid, shitty-ass problem. All these physics problems asking you a billion different things in one question. Part B is at the center of a cube face. So what that means, I'm no longer in the middle of the cube, I'm at the middle of a cube face. A cube face is one of these squares, and I'm at the middle of it. So I'm maybe right here. Yeah? So if I'm right here at the middle of my cube, I can see this face that I'm on the center of. I'm the same distance from each of these 4 corners, right? So that's going to be 4 of the charges are all going to have the same potential. And then I'm also the same distance from this corner up to here. I'm the same distance from all of these back points, right? So I'm going to have 2 different equations. I'm going to have V equals 4 times K times Q over some R1 plus another 4 times K times Q over R2. One of them is the front face, one of them is the back face. So how far is it from one of these corners to the middle? I have to step in X and Y only, X, Y, and Z. So I can go over and then down and get the hypotenuse there. That's what I'm looking for. So how far over do I go? From the corner to the middle. A over 2. So R1 is A over 2 squared. How far from the top to the middle? Top. Also A over 2. Take the square root of that, and that's the front face, because it's giving me over, then down, giving me that hypotenuse. Yeah? Now I need to get from the back corner up to here. How far is it from the, so I'm going to get the hypotenuse of the triangle that starts here and ends here. So I need to go up, I need to go either in or down, and then I need to go over. So first, from the back to get up to the front, how far is that? A. So R2 is going to be A squared. And then how far from the corner to the middle? A over 2. And then how far from the middle to the middle? From the top to the middle, A over 2. So there's my R1 and R2, and I would plug those in for my final answer for my B. Questions on that? Now, as you start thinking about the exam that will be coming up at some point, would I give you the exact same question here? What could I change about this? The letters. I could just flat out change the letters, give you a cube that's size B, and then when you all put in A's, I know you just memorized the answer and I take points on it. Still pass. What else can I do? I can give you numbers. What else can I do? Nothing else. There's one other big thing I can give you. I give you a sphere. Sphere would be really easy, right? If I'm at the middle of a sphere, I'm always R away. I can give you a rectangle. If I give you a rectangle, that changes one of these dimensions. Still the exact same concept. You just change one of the sides, so maybe you have B over 2. Maybe I do 3 different side lengths, and you have A, B's, and C's. Same concept, same way to get to the answer. It's giving you insight into how my diabolical mind works. So any other questions? No questions on that part? Let's do the last one. At the center of a cube edge. So the center of a cube edge is going to be right here in the middle. We'll do this top cube edge. Right there. So I can see right away I am a distant, how far am I from this corner? A over 2, how far am I from this corner? A over 2, so that's 2 that are the same. So I've got 2KQ over R1. So V equals 2KQ for R1. That got me these two corners. How about this corner? How far? I have to go up, and then I have to go in. Then I have to go up, and I have to go in. So these two are the same. Yep. So that's another 2. Plus 2KQ for R2. These back corners. Up, then over, up, then over. But that up and over is the same as that up and over. So these bottom corners are the same as these back corners. So what does that mean? 4KQ over R2. And then I've got the very back bottom corner. I have to go up, I have to go forward, I have to go up, then I have to go over. To go forward, then up, then over. So I've got 2 of these. These are both the same distance. I got 2KQ for R3. What's R1? R1 was from this corner to the middle. How far is that? Here to here. A over 2. Do I have to do squares? Square roots? Am I doing a hypotenuse here? No, I'm just traveling straight along there. So that's just A over 2. Okay, how about R2? So from the bottom up to the top and then over so that I'm getting this hypotenuse. Up, over, that's the hypotenuse. Corner. So how far is it from the bottom up to the top? That distance is A. So R2's got to be A squared. And then how far from the corner to the middle? That's got to be A over 2 squared. And I take the square root. And then R3. R3 is the back bottom corners. So I need to go up to the front. So how far from the back to the front? That's got to be A. That's going to be A squared. How far from the bottom to the top? That's going to be A squared. And how far from the top corner to the middle? A over 2 plus A over 2 squared. Square root. So there's my R1, R2, and R3. There's my answer. If you want to play with this, pass it around to the tables, take a look at it. And I will print more. Any questions on this problem? No? It's going to be a very confusing YouTube video. Because I'm here pointing at things and people are going to be listening and watching and they're going, what the fuck are you talking about? It'll appear in the comments. All right. The other problem people wanted to see was problem number 49. 49 is the kind of problem that I hated to see when I was a student. Because it seems cruel. It seems cruel to me. They give you this problem. It can be shown that the electrostatic potential of a dipole P placed at the origin and oriented parallel to the z-axis is this big giant equation V equals P over 4 times pi times epsilon naught times z, all divided by x squared plus y squared plus z squared, all of that raised to the 3/2 power. By differentiating this potential, find the components Ex, Ey, and Ez of the electric field produced by the dipole. That seems really hard. That seems very confusing. I feel like they're telling me what to do, but they're not telling me what to do. It just confused me when I was a student. They really are telling you exactly what they want you to do, though. They want you to find the electric field components. And the electric field is always equal to the negative partial derivative of something with respect to direction. I think that's the format that your book gives it in. It's curly D. Partial derivatives. How many have seen partial derivatives before in your life? What does a partial derivative mean? Does anybody know what the partial derivative means? It makes your life much easier. It really does. So if I want to find the electric field that this potential creates in the x direction, then instead of doing the partial derivative with respect to all different directions, I do this negative dv, that curly d, dx. And what that means is that the only thing that I need to treat like a variable in this problem is the x. So when I'm taking the derivative, the x is the variable. Y and z, p, epsilon naught, all of those, I can treat those as though they're constants. They're not variables. I don't have to differentiate anything to do with those. The only thing I have to differentiate with respect to is x. Here I have a little big complicated equation. How do we want to take this derivative? We can do product rule, we can do quotient rule. What do you prefer? Or do we not care? Anybody vote for quotient rule? Some of you are voting for the quotient rule. Quotient rule is harder. I recommend product rule. But to do the product rule, you have to get rid of the quotient. How do you get rid of the quotient? How do I put that x squared plus y squared plus z squared to the 3/2 on the top? I raise it to the negative exponent. So I can rewrite this as negative derivative with respect to x of this giant equation. P over 4 pi epsilon naught times z times x squared plus y squared plus z squared, all of that raised to the negative 3/2. So now I have a product rule that I could potentially do. Do I really have the product rule here? No, I don't have the product rule. Because I only have one x, well, an x squared. This p over 4 pi epsilon naught z, if I take the derivative of this, assume this is my first term, first times derivative of the second plus second times derivative of the first. The derivative of this with respect to x, are there any x's in here, this first part? No x's. So as far as x is concerned, this is just a number. What's the derivative of a number? 0. So we don't have to differentiate. Right? We don't have to do first times derivative of the second plus second times derivative of the first. We just take this derivative. So when I'm taking this derivative, I need to follow, oh gosh, what's the rule for something raised to a power? How do I take the derivative of something raised to a power? Chain rule. How does the chain rule work? I take whatever my exponent is. My exponent comes out front. So bring your exponent out front. I've got a negative in front of the derivative. I bring my exponent out front, negative 3/2. And then I write down everything else that I have. I write down the coefficient in front. I write down everything in the parentheses. I just repeat that. I write that back down again. So I've got p over 4 pi epsilon naught times z times x squared plus y squared plus z squared. And in the chain rule, power rule, whatever you call it, after you take the negative 3/2 out front, you take whatever your exponent is, you take that exponent and you subtract 1 from it to find the new exponent that you raise it to. So I have negative 3/2 minus 1. What does that give me?
Negative.
So I have to the negative 5/2. And the part that everybody forgets to do in the chain rule, I then have to take the derivative of everything that's inside of this parentheses, everything that's being raised to the exponent. So let's take this derivative with respect to x. So what's the derivative of x squared with respect to x? 2x. Okay, so that's a 2x. I close that up. That's done. That's the answer. What? No. Would that be the answer? I got to take the derivative of y squared. What's the derivative of y squared with respect to x? What does x think y is? Does x think y is a variable? No, thinks it's a constant. So what's the derivative of y with y squared with respect to x? 0. What's the derivative of z squared with respect to x? 0. If it's not an x, it thinks it's a constant. So these two both go to 0. There are no derivatives there. That's your answer. That's it. Your book answer might look a little bit different. They might have simplified, but that's the answer. Leave it like that. Don't simplify, then you make mistakes. Then I have to find your mistakes. That takes forever. Most of you have terrific handwriting. So there's my answer. There's my electric field in the x direction. Other nice thing about this problem, let's take the electric field in the y direction. Let's find the y direction. Y direction is almost the exact same thing. What changes in the y direction? I have 2y. How about the z direction? Z direction is the exact same thing? What fucks up the z direction? I've got the z right there. So I have to do the product rule. Should we do that? Let's do that. Let's see this in the z direction. So we know the x direction, the y direction is the exact same. We'll write it down for posterity for the one random guy in Alaska that's going to watch this in 10 years and have his mind blown. Times x squared plus y squared plus z squared to the negative 5/2 times 2y. Blew your mind. You're welcome, guy in Alaska. Now we need to do EZ, which coincidentally is not very easy. Derivative with respect to z. So let's do the negative derivative with respect to z of all this stuff. P over 4 pi epsilon naught z times x squared plus y squared plus z squared to the negative 3/2. I have to take the derivative of all of this. I do have a product now because I have a z in here and I have a z in here. So I have two different terms that I'm multiplying together and they both have z's in them. So I have to do the product rule. Product rule tells us that the derivative of a product is the first thing times the derivative of the second. So let's do that. Let's specify this is the first part and this is the second part. And the product rule says that the derivative is the first times derivative of the second. Have you ever seen this prime notation before? So that 2 prime means it's the derivative of the second. Plus the second times the derivative of the first times 1 prime. So let's go through and do the algorithm. The first variable. What is the first variable? First element. P over 4 pi epsilon naught z? Sure. And then I need to take the derivative of the second piece, that whole second half. How do I take the derivative of this whole second half? Take the negative 3/2 down up front. So I've got negative 3/2. Write down everything that was just inside of that parentheses. X squared plus y squared plus z squared. Raise that up to the negative 5/2. And then what do I have to do next? Take the derivative of the stuff in the middle. What's the derivative of x squared with respect to z? 0. Y squared with respect to z? 0. Above this, what's z squared? 2z. Times 2z. So that's the first times the derivative of the second. Now I need to add the second. What's the second piece of that whole thing? X squared plus y squared plus z squared to the negative 3/2. And now I need to take the derivative of the first term. What's the derivative of p over 4 pi epsilon naught times z? We won't put this in the video. They're all shouting out the correct answer, I promise. What's the derivative of 5z with respect to z? 5. What's the derivative of 1,260 z? 1,260 What's the derivative of xz with respect to z? X. What's the derivative of p over 4 pi epsilon naught z? P over 4 pi epsilon naught. There you go. Boom. That's p over 4 pi epsilon naught. Is that it? Really? You sure? Is there anything else?
No.
What are we missing? One little thing. There's a negative on the outside of all of this. Because e is the negative derivative. But there's your answer. Is it big? Is it messy? Is it right? Sure. Right? Your answer's going to be big and messy. Maybe it'll be a whole crap ton of letters. That's fine. Questions on that? No? Did that help? Yeah? That's what I'm here for.